Hello, hello, hello. Welcome back, guys. It is Tuesday, the 9th of June, and today I'm going to be doing paper 2 from the MEI series from OCR, the OCRB. I know that a lot of people have been saying there's not as many resources available for the OCR MEI, and I've seen some comments asking me specifically for paper 2, since I know that paper 2 is coming up this week. So we just wanted to drop in and quickly drop a live solve for that. So that hopefully you guys find that helpful before your paper this week. So without further ado, let me just launch straight into it. Apologies for the slightly delayed start as well. I was having some problems with the emulator software for the calculator that I can kind of bring on the screen. But I seem to have got it sorted. So hopefully everything should be fine. Now, all right, let's just launch into it. I'm not going to time it. Because I think with the OCR MEI, I've tended to be okay in the past in terms of timing. But let me just launch into it. Okay, so here, question 1. So section A, usually not too bad. Determine the sum of the infinite geometric series. Well, A is equal to 9. R is equal to -1/3. And so the infinite sum, the sum to infinity, which is given by A over 1 minus R, would be 9 over 1 plus 1/3. So it's 9 over 4/3, which is 27 over 4. Okay. Question 2, we have an equation of a circle. All we have to do is to complete the square on the x and the y. So taking that divided by 2 gives you your -6. You square that for 36 and subtract. Y plus 4 squared -16. Now, I know with the structure of this paper, I'm not expecting it to get difficult in section A. So I imagine this will be just a fairly straightforward running through. 36 and 16 and -3 is 49, which means that the radius of the circle is 7, which is the square root of 49, and the coordinates of the center are going to be 6 minus 4 from solving each of those brackets for the x and y coordinates. Show detailed reasoning. Find the smallest possible positive integers m and n such that that thing... Okay, they're overcomplicating it. Let me just actually solve this for a second. All right, so let me just deal with the left-hand side, because I know I can. Right, so the first thing I'm going to do is deal with the negative sign, which is just going to flip the fraction. Now I'm going to deal with this over 2, which means square root, which will turn that into 7/8. And then I'm going to cube the whole thing. And that is what I'm going to rely on the calculator for, which is going to be 343 over 512. And that's going to be very simple to check. Is that the whole question 3? Yes, it is. All right, question 4. Biased die faces from 1 to 8. Discrete random variable is the score obtained when the dice is rolled once. Probability distribution is shown. Determine the value of P. Okay, well, with any probability distribution, the basic idea being tested is that the sum of the probabilities is 1. So 1, 2, 3, 4, 5, 6, 7p. So 10p is equal to 1. P equals 0.1. The end. Find the probability that a score of at least 4 is obtained when the dice is rolled once. So the probability of at least 4 is that x has to be bigger than or equal to 4. Hello, hello. So 1, 2, 3, 4, 5, 6, 7. So it's 0.7. C, determine the probability that a score of 8, hold on, we got something new happening now. So the dice is now rolled 30 times. The second I see that in stats, my brain immediately goes to the binomial distribution. So we're going to call that y because x is taken. It will be distributed binomially with n equals 30, and p is the probability of scoring an 8, which is 0.3. So y is the number of 3s. The probability of, sorry, it's the number of 8s, and the probability of getting an 8 is 0.3. So rolling 30 times, determine the probability that 8 occurs exactly twice. So P of y equaling 2. In fact, let me bring across this guy because we want to go to, do I know how to press my buttons? I don't think I do. Distribution, there we go. I much prefer the other one, but the free trial on that ran out. So I'm like, no, I have to actually use a legitimate calculator. Why? Till that one equals x equals, nailing it so far. All right, guys, let's press the buttons. I'm so good at pressing buttons. Num trial 30 p 0.3 execute. Tiny, what do you? Okay, I'm just gonna have to deal with that. So that's 0.0018. Okay, I'm just gonna roll with that. It's gonna be fine. It's gonna be fine. Guys, trust me, get to the point where the math is the easy part and the pressing buttons is the hard part. Then you know you're in a good place. Determine the exact length of AB. My preferred method is pathing. So if we're going A to B, that means going from A to O and then from O to B. So A to O would be -3, 1. And then it would be 5 minus 3. That would give you 2 and -2. And the exact length of AB would be the magnitude of that, which is just from the Pythagoras. So this means 2 across, 2 down. And so you can use Pythagoras to say that the magnitude is 2√2. And that's the exact length. Question 6. So we have a parametric equation of a circle. Determine the Cartesian. Well, this is more of a further math thing. But what you can do... No. This is totally legit. This is totally legit. Ooh. The pathing method. Yeah, I'll go back and explain the pathing method. Why not? So the idea of pathing, for me, it only makes sense if I want AB, I need a path that starts at A. So for instance, I could just randomly draw on... Oh, no, lies. This is kind of arbitrary, but if that's O and that's A and that's B, then that is vector OA and that is vector OB. When I say pathing, I mean, how do I get from A to B? Well, I go from A to O, and then I go from O to B. And that's what I'm telling myself here. And then I ask myself, how do I get from A to O? I do this. How do I get from O to B? I do this. And so putting it together is how I get from A to B. In a simpler one like this, you can just use the form that you've been using, but in more complicated situations, I use this to make sure I, for instance, never make a sign error, because it's quite common for people to accidentally add these together and get 8 minus 4. And so by using pathing, it makes sure that you're really considering the signs. Have you gone like against the vector? Something like that. Okay, so going back to question 6. Right, parametric equation here. What we're going to have to do is get rid of the parameter theta, because we can see that theta does not exist in the equation we're trying to get. So what we're going to do is to find in the first one that cos theta is equal to x plus 3 over 2. And in the second one, sine theta is equal to y minus 1 over 2. And we're going to use the identity that cos squared plus sine squared equals 1. So that means that x plus 3 over 2 all squared and y minus 1 over 2 all squared equals 1. So let's multiply both sides by 4, and we get x plus 3 squared and y minus 1 squared is equal to 4, and that is the Cartesian equation. Sweet. And then question 7. We have binomial expansion with a positive integer power, which means we can just use the year 12 method. Let me zoom out a bit so I can see the whole question in one go. So the coefficient of x to the 8. So we can get straight to x to the 8 by saying that's going to be 12 choose 4, 2x to the 8, k to the 4. And that is the term that's going to get me x to the 8. 12 choose 4 is 495. So 495 times 2 to the 8 times k to the 4 is equal to 79200,000. So 495 times 2 to the 8 is, oh God, why are you doing this, paper? Can you just like not? Okay, so you get numbers and then you do stuff with them. And this, I don't know if you guys have the same reaction. As soon as numbers get ugly, I kind of like, ew, I'm uninterested now. Why are you doing this? Go away. But oh nope, that does come out right because k is just equal to 5, which is quite nifty. Okay, not too bad from section A. Now we've got our section B. It's going to ramp up just a little bit. So zooming out to see the question. Garden center stocks stuff displayed in 10 rows, each of 120. Collect a sample of the heights. Explain whether the data is simple. Each plant in the front row. No, that's not simple random. Simple random means that every plant would have an equal probability of being selected. Don't have equal. Probability of being selected. I'm going to go with that. We'll see what the exact wording is. This is why we always do mark scheme analysis. So because I want to see if they're defining it as whether the individuals have the probability of being selected, or as I see sometimes, whether every possible sample has an equal probability of being selected. These little wording things tend to matter in the stats. These are the kinds of things you tighten up at the last minute. So data is shown in the cumulative frequency. Owner states that at least 75% are between 40 and 80. Show that the data supports the statement. So between 40 and 80, that looks to be 18. That looks to be 110. So 110 minus 18, I can't be bothered, is 92. 92 out of 120 times 100. Still cannot be bothered. Is 76.7%. And because 76.7 is bigger than 75, then it is true. Explain whether all samples would necessarily support the owner statement. Huh. Sample the highest plant, recording the height of each plant in the front row. So those are just the front row, 120. I would say this is not necessarily so. Because it could be that the ones in the front are bigger. I'm going to say no, but I don't know what exactly the wording they want. Whether all samples would necessarily support the owner statement. I would just say variation in samples means some samples would have less than 75%. I doubt I'm going to pick up this, Mark. Again, the really annoying technical wording here. Or maybe I'll just say random variation as well. I mean that some samples might have less than 75%. I don't know. This is why I don't like stats, guys. This doesn't feel like proper math. You know what I mean? Like I want to solve things. Boo. All right. Question 9. And that's part of what I'm doing as well as reacting to the paper. And hopefully you guys have like similar reactions to me. So pre-release material, which by the way, I don't know the pre-release material for the OCR MEI. So good luck to me. Some of the data for Camden is shown. Years quoted referred to the end of the financial year's K. Cool. Explain whether these data are a sample or population. God damn it. I hate stats, guys. I really do. This is not fun. All right. Bad. Well, it says some of the data for Camden. Well, hold on a minute. So this is concerning the median income of taxpayers in different areas of London. Well, it's only 1 mark, so it's not too bad if I lose out on this. Explain whether these data are a sample or a population. I would say sample. But they are, well, it's the median, though. It's the median comes from the population, presumably. Well, I suppose we're only sampling the medians. I'm just going to pause a minute just to answer the common question. So common question regarding Oxbridge interviews. Where can you find problems for engineering physics? First of all, you have my streams. Second of all, I would go to the PAT tests, the historical PAT tests. You can go to iwanttobeanengineer.com, I think it's called, something like that. Anything that tests the front edge of your math and physics ability is something you can do. I have streams going through all the different types of STEM interview questions, and you can kind of use that to prepare yourself as well. And just get really good at thinking through weird abstract things, is what I would say. You've got ages, but I would say at this stage, the best thing you can do is PAT papers, especially because 2017, 2018 had some really good ones that I actually use in interviews. Right, heading back into the live solve. So I'm gonna say it's a sample. I might be getting this wrong, guys. I apologize. If I am, then we'll pick it up in the mark scheme. Explain whether these data are. Let me just check my time. Yeah, we're good. So this is a sample because not all taxpayers included. So I'm just gonna say that. I hate stats. I hate words. Did not come here to write sentences. Silly stats. Okay, so a time series for the data is shown below. So it looks linear. Oh God, is this on your spec? I'm going to assume that means for linear estimation. Median versus year. Use this model. Okay, so that is the model. Use this model to find an estimate for the median in 2009. Okay. Y is the year. Okay, so I'm just going to plug 2009 into this model. So I'm going to say 1115 times 2009, and I'm going to subtract 2212, 950, and I'm going to get 27085 pounds because we're modeling. Give 2 reasons why this estimate is likely to be close to the true value. 1, we're interpolating. So it's based on, so in other words, it's based on data from 2004 to 2011. And 2009 is in that range. And the second one they're likely looking for is the fact that we are using a linear model. Linear model looks to be appropriate because the data, hold on. So the linear model is appropriate to use because you could, for instance, get something, but if they were scattered all over the place, then it wouldn't necessarily be a great model to use. Whereas this, because they actually do look like they lie close to a straight line, then we know that the model is a good model to use. So because, and they love, by the way, like some commentary now, this is a very common question. They love to ask this about linear regression. Because the data points lie close to a straight line, a linear model is appropriate. Close to straight line. So this is the rare instance of a wordy one that I can actually do, which means I've now jinxed it and I'm not going to get those marks. So use your knowledge of the pre-release material. Good luck me. I know the Edexcel one, and you should know your pre-release material for your specific board. Whether the model used in Part B would give a reasonable estimate. I have no idea what they're talking about here. I'm going to say yes, it's a reasonable estimate. Let's just make something up. Unless we're supposed to know that. No, when did the financial crash happen? That was before that, wasn't it? I should know, I was there. Use your knowledge of the pre-release material to explain. I'm just going to say, because median incomes go up over time. I don't know. Silly. Know your your pre-release material. But if you don't know, then you give your best sensible guess. And then we get into the actual math. Yay! I know. No, the Edexcel large data set is fine. No slander on the large data set. You just got to know the names of the columns, what type of data they measure. The only weird one is knowing that. Let's have that conversation. So the only weird one for Edexcel is knowing the units for, first of all, visibility is in decameters, which is weird. And the units for pressure are hectopascals, which is 100 pascals. If you do physics, though, you know that the atmospheric pressure is 101 kilopascals. So that becomes 1010 hectopascals, and that's what you expect. Beyond that, though, you got to know how to work with trace, which is between 0 and 0.05 millimeters of precipitation. Yeah, and you have to know that a lot of stuff is not available, especially from the 1987 data. And you have to know the locations, the 8 locations, and you have to know that it's May to October of 1987 and 2015. But apart from that, you should be fine. Like, if you sit down and learn it, it's largely very good. Okay. Now some actual math, and I feel much more comfortable now. Ugh. Oh, there was. I know the exact question you're talking about. Yeah, that was nasty. That's not even your fault. That's not even your fault. That, you honestly, fair enough. That one was stupid. I know the one you're talking. It's to do with, because it was like on the coastline, and so the wind was going to be coming from a certain direction. That was stupid. I will grant you that. Most of the time, they're not stupid, though. I know that question. All right, so this is going to be a classic by parts. The reason why is we have 2 functions of x multiplied together, and this is not of the form of differential times original to power. And this is an x, and which is going to be the u in the integration by parts, because your only candidates are ln x, and x squared, unless your syllabus has iterative integration, but, you know, whatever. So what we're going to do here is to say that u is 4x, which means that du dx is equal to 4. And we're going to say that dv dx is equal to cos 2x, which means that v is equal to a half sine 2x. So that becomes, so the integral becomes uv. So we've integrated that. So it becomes 2x sine 2x between pi over 4 and 0 minus the integral of 2 sine 2x dx. Now, this formula is on your formula sheet if you require it. So it's uv minus the integral of v du dx. So I'm going to, I'll plug it in now. Why not? So that would be pi over 2 sine pi over 2 minus 0. And then this becomes the negative of, now this becomes, well, in fact, well, hold on, this becomes minus 4, no, minus a, why is brain, you can do it. You can do it, brain. Minus cos 2x, because cos, minus cos differentiates to sine. Yes. Between final. Now, this is where I'm going to be using my checking, certainly. But this becomes pi over 2 sine pi over 2. Now, I'm going to take the minus minus and turn that into a plus. Yeah, no, I'm going to do that, but I'm going to, because there's a risk of a sign error, and I don't want to make an execution error, I'm just going to do it as a separate line. Also, I forgot that sine pi over 2 is 1, so that just becomes pi over 2. And this becomes cos of pi over 2 minus cos of 0, which is pi over 2. Cos of pi over 2 is 0 minus 1, so it's just pi over 2 minus 1. Okay. So 11a. The variables x and y, oh, let's zoom out so I can see this, such that dy dx is directly proportional to the root of x. In other words, dy dx is equal to k root x, where k is some constant of proportionality. Dy dx equals 3 when x is equal to 4. So 3 equals 2k, and k is equal to 3 over 2. This gives us dy dx in terms of x, which is that dy dx is 3 over 2 root x. Good. Now, we can integrate this and say that if dy dx is equal to 3 over 2x to the half, then y would be, raise the power on that becomes 3 over 2. You divide through, and then you add c. And we can plug in the fact that y is equal to 10 when x is equal to 4. So 10 is equal to 4 to the 3 over 2 plus c, which is equal to 8 plus c, and then c is equal to 2. Which means that y is equal to x to the 3 over 2 plus 2. So then question 12. It's given, okay, we have a function here. We have g of x, we have h of x. Explain why f of x is not a function. What? Let's think about what this means. This would be a one-to-many function. So a function, well, it would be a one-to-many mapping, but a function, I think, has to only have one y value for every x value, whereas this has two y values for every x value. For 1 mark, I think saying it's one to many. I mean, I'll just, yeah, anything I've said, assume I've also written down. So find g of h. That means we plug h into g. So g of h of x is equal to, now wherever I see x, I'm going to put the full h of x. So x squared plus 2 all over x squared plus 2 minus 3. In other words, it's x squared plus 2 over x squared minus 1. State the domain of that. Well, h of x was all real x. But that has gone into there. The y values from h have gone in for x. And these y values, so we know that h of x has to be bigger than or equal to 2. And those are the values that go in for x here. Oh, Ugla, congratulations, you finished your physics. Absolutely no worries. Go on and do brilliant things. I'll stay here and I'll carry on. All the best. So, we've got this. H of x is going into the g of x. And because these values are already included in that, I'm just going to say, especially because it says state, it's just going to be x is bigger than 3 as well as the domain of that thing. Or is that true? That might not be true, actually. Is that... No. We need x to be bigger than 3, which means we need x to... Oh, I think I might be wrong, guys. Why is this state? This shouldn't be state. This should be calculate. Okay, here's my logic. This is more tricky than it looks, in my opinion, unless I'm overthinking this. So we need the things that go into g of x to be bigger than 3, which means we need h of x to be bigger than 3. This happens when x is... So in other words, we need x squared plus 2 to be bigger than 3. So we need x squared to be bigger than 1. This happens when x is less than minus 1 or x is bigger than 1. I think when I put that in for h of x, that gives me values for which g of x is valid, and I can put that in. So I think that's the domain, unless I'm overcomplicating it, which is entirely possible. Hello, hello. Right, 13. So a large supermarket chain advertises that the mean mass of apples of a certain variety on sale is that. So we have a mean of the apples. Following a poor growing season, it's believed that the mean mass is less than that, so carries out a hypothesis test, collects a random sample, gets some evidence. State the null hypothesis. Well, the null hypothesis is going to be that the mean is equal to 0.14 kilograms. It's what we thought before. The alternative hypothesis, H1, the mean will be less than 0.14 kilograms. You're saying, as I wasn't there yesterday, wanted to say that paper 3 was decent for physics. In particular, 3A, which is usually bad. That is the general consensus, is that physics, actually across the board, physics this year was not bad. The biggest complaint so far this year has been Edexcel Math Paper 1. So yes, it may mean that the grade boundaries are higher, but hopefully it means that you have done well and actually shown your ability to the best of your ability. So here we've got your null and alternative hypothesis. Defining the parameter used. So let's say me equals the mean mass of apples. B, write down the distribution. So X will be distributed. How many did she take? N equals 80. So we're testing for the mean. So this has to be normal. Honestly, Noel, if you thought the Edexcel paper one was that good, that means you're probably higher up the grade boundary as well, higher up the curve, which means you've likely done well. So hats off to you, but don't tell anyone else. Distributed normally with a mean. We're going to assume that the standard deviation is the same. So for these 80, I think these 80 have a standard deviation of that. So X is distributed with this. I'm going to take that as being the standard deviation of a single apple as opposed to the 80. So I'm then going to say that X bar is distributed normally with, and again, that's going to be 0.14. And that's going to, sorry, that thing's squared. And I'm going to say that 0.0198 all over the root of 80. And that will be my new standard deviation. And I'm going to say the X bar is the mean of 80 apples. Okay. Determine the critical region. Must I? I hate critical regions. Normally it was 0.14, 0.0198 all over the root of 80, and that thing's squared. Cool. Critical region means I want to find where, so I know the probability of X bar being less than a value is 0.05. Any distribution work I'm going to bring over here. Exit, normal, go. Okay, so I think what we do here, first of all, let's set it to lower tail. Let's say X is, I don't know, 0.13. That is 0.0198 divided by the root of 80. And the mean is 0.14. Let's execute on that, go. But we want to change that probability to 0.05. And then you get this X value, 0.1363. So therefore, the critical region is X bar is less than 0.1363 to be significant. Okay. Carry out the test. 0.1316 is less than 0.1363. Therefore, we reject H naught, and we can't spell. We reject H naught and say that there is sufficient evidence to conclude that, and then you restate it in the language of the question. So to conclude that the mean mass of apples is less than 0.14 kilograms. Okay, 14A. Not the pre-release material. Why? I hate it so much, guys. I don't like it. Why? I'm tired. I don't want to do this. Okay, fine. So the pre-release material contains information concerning the median income. Really, does it? I hadn't clocked that. And the percentage of all pupils at the end of Key Stage 4 achieving 5 or more GCSEs A star to C, including math and English. Okay. Whether there's any relationship with reference to 14.1, explain how the data should be cleaned before analysis can take place. Get rid of City of London. There's no GCSE data. Let's go for that. Okay, so 14, what's happening here? After the data was cleaned, you draw a bunch of stuff. That's a very low product moment correlation coefficient. Why? Give 2 reasons why it may not be appropriate to use a linear model. This is kind of what I was saying earlier. So I'll say 0.3743 is not close to 1. Data points do not lie close to a straight line. To a straight line. We can also say maybe that there's only a weak positive correlation. That's just getting me so what I'm trying to do is to use any opportunity to demonstrate what I know from the syllabus. And so using a phrase like weak positive and correlation is just something, and so it just demonstrates a knowledge point that I've picked up. So I may as well use it. Okay, so further analysis. Student identified 3 outliers in total. Use the information here to determine the range of values of the median income, which are outliers. Median was this with the standard deviation. So I'm guessing what they're saying is it's going to be median. Oh. Because normally it's Q3 plus 1.5 interquartile range, but we don't, we have mean and standard deviation. Sorry, apologies. In which case outliers are going to be at mean plus or minus 2 standard deviations, right? So upper limit would be 27,216 plus twice the standard deviation. And when I run that, I get 35,571. And the lower limit would be 27,216 minus twice the standard deviation. Which is 18,861. And again, I'll stick the pound signs on because units. Okay, so that's 14.3. I've done that. Use the information in 14.3 to determine the range of values of the percentage of blah, 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 which are outliers. Well, I need to do the same thing there. So I'll do upper limit for GCSE, which is 61.0 and twice 5.32. So 61 plus 2 times 5.32 is 71.64. And I'll do the lower limit for that one as well, which is 61.0 minus twice 53. Whatever that is. Stats just has always felt like you just do stuff. You don't solve anything. I hate stats. It's also a really big gender divide as well. Guys stereotypically enjoy the mechanics and girls stereotypically enjoy the stats. And that's not me. That's just observed. That's just what I see in my practice. So the range, which are outliers. So in other words, outliers are kind of beyond that. On the copy, circle the 3 outliers. So in other words, I'll sort of say, because it does ask for range. So outliers are so median income less than 18,861 or income bigger than 35571. And outliers here are for, I'll just say GCSE. So either the GCSEs are less than 50.36% or the GCSEs are bigger than 71.64%. So let me zoom out so I can kind of see what's going on here. So the median income, so there's no one less than the lower one. So I'm looking at the upper one, 35. So you are bigger on income. You are bigger on GCSEs. You are bigger on income. Okay, I'm going to stick with that. That was interesting. Was it? Nah. And by the way, I haven't seen end of questions and it says turnover, so I know I'm not done yet. Explain whether the new value of the PMCC would be between... Okay, decided to remove these outliers and recalculate it. Huh. I have no idea. In this case, I genuinely do not know. God damn it, MEI. What are you playing at? I can see why people wanted me to do paper 2. This stuff is not fun. Because again, I feel like this wouldn't show up in the EdXL syllabus. All right, let me just sort of do my best here. Because in practice, I don't think that's the issue. The problem is not that these are outliers within their respective things. It's that like even when they're not outliers, they're still far away from the line, right? But the point is, would that make it a better straight line or a worse straight line? I can kind of see that it makes it a worse straight line because now they're all just clustered together. Like those outliers were the only thing pulling it into some sort of distant line-like shape. I'm going to go, do you know what? I'm going to risk it. I'm going to say it's between 0 and 0.3743 because now they're much more clustered together rather than spread out in a straight line. So I'll just say that data are just more grouped together. And less spread out on a line. Okay, so question 15. Oh, this is fun. Okay, here we go. Back to some actual math. Love actual math. So ln y plus y plus whatever that is that. Find the equation of the normal. In order to do this, we need the gradient, and then we'll do -1 over the gradient to get the perpendicular gradient. In order to get the gradient, we have to do implicit differentiation. So here, I always do d thing dy dy dx. So d thing dy is 1 over y times dy dx. And this is first, d second, plus second d first. And that 8 differentiates to 0. At this point, I'm going to substitute immediately. Oh, no, I can't. Oh, yes, I can. Because when y equals 1, we get that ln 1 plus x cubed equals 8, which means, and ln 1 is 0, which means that x cubed is equal to 8, which means that x is equal to 2. Now, if I plug those into here, and I really should have done those in the opposite order, so let's just pretend that came first, right? Finding the x, now that I know my y, we can plug that in here and say that 1 over 1 dy dx. It's just much easier than rearranging for dy dx. I much prefer substituting. Plus 8 dy dx plus 12, which is 3 times 4 times 1, equals 0. And then you can see this is going to be very simple. 9 dy dx equals minus 12. Dy dx is minus 4/3, which means that the perpendicular gradient is 3/4, which means that, again, y minus 1 equals 3/4 x minus 2. And we want this to be integers, so let's multiply the 4 across and multiply the 3 into that bracket. And I'll bring this, so I'll say that bring these across and say 0 is equal to 3x minus 4y minus 2. And I think that's the normal. Cool. 16, you gotta calm down, paper. You gotta stop. Too many questions. Research conducted by social scientists show that 16% of young adults smoke cigarettes. Gross. 2 young adults are selected at random. Determine the probability that one smokes and the other doesn't. So we're going to assume each of these are independent at 16%. So one smokes and the other doesn't would be either the probability of smoke and then not smoke, or not smoke, smoke. So in other words, it's smokes and doesn't smoke, or, which is plus, not smokes and smokes. Okay. So 0.16 times 0.84, which really times 2, it's 0.2688. %75 drink alcohol, 66 drink alcohol but do not smoke cigarettes. This looks like a two-way table to me. So alcohol, not alcohol, smokes, not smokes. So 75% drink alcohol, which means that 25% do not. 16% smoke, which means that 84% do not. 66 of young adults drink alcohol but do not smoke. So that's 0.66, which means this is 0.09 to make up the rest of the 0.75. That's 0.707 to make up the rest of the 0.16. And this is 0.18 to make up the rest of both of those probabilities. Okay. Determine the probability that the selected young adult does smoke but does not drink. So S, no alcohol, 0.07. A young adult who drinks alcohol is selected at random. Determine the probability that this young adult smokes. So this is the probability of smoking given alcohol. So out of the ones who drink alcohol, it's the ones who also smoke. And this comes from the formula in your formula book. The probability of, in fact, let me just do that in full for anyone who needs it. It would be the probability of S and A all over the probability of A, which is where the 0.09 came from. And 0.09 divided by 0.75 is 0.12. Now, D, use your answer to C. Explain whether the event that a young adult selected at random smokes is independent of the event that a young drinks alcohol. So if it's independent, it would not matter whether it was given alcohol. The given alcohol would not do that. So in other words, if independent if, this is what they're testing here. If the probability, if the probability of S given A equals the probability of S. Now, 0.12 does not equal 0.16, therefore not independent. Okay. God, seriously, how many questions are there? Calm down. What are you doing, MEI? All right. Oh, yeah, okay, fine. A bit of trig. Never hurt anyone. So 2 sine x plus sec is 1 over cos x is 4 cos x. Let's multiply by cos x everywhere. That's just so wrong. Hold on a minute. I'll try that again. So 2 sine x cos x plus 1 equals 4 cos squared x. Now this is sine 2x. Huh. All right. You're throwing up a little bit of a challenge, aren't you? Because I could turn you into sine squared, but how would I could turn you into cos 2x, maybe? Interesting. Huh. All right. Let me try, hold on. So cos 2x is 2 cos squared x minus 1. So that would be 2 cos 2x plus 2. But I just don't think that's how they want you to do it. Sec is 1 over cos. I mean, in theory, I can use the fact that this is a linear superposition of sine and cos, but like, yeah, harmonic forms. But I'm shocked because I'm not used to seeing harmonic forms show up here without them prompting you. This is interesting. Because yes, I could say that this is let's say it's of the form of r sine of 2x minus a or minus alpha. Then I can say that that would be r sine cos minus r cos sine. And so I could say from that, oh, I've done that the wrong way around. No, I haven't. I can say that r sine alpha is equal to 2, and I can say that r cos alpha is equal to 1. Like, I do have the skill to handle this. I'm just surprised is all. So alpha equals, and this is in radians, so I need to make sure I'm in radians. So inverse tan of 2 is 1.107. And you get the r from squaring both and adding them together. So r squared is equal to 5, and r is equal to root 5. In case you need to know why, it's because if you square that, you get r squared sine squared. And if you add r squared cos squared, that would be your 2 squared plus 1 squared. Because that squared is equal to 2 squared. Cos squared 1 is equal to 1 squared. but the sine squared plus cos squared is equal to 1. So it becomes r squared into 1, which is 5. So r is equal to root 5, just in case you need that. I'm just so surprised to see harmonic form come up. But anyway, we do get in the end that root 5 sine of 2x minus 1.107 is equal to 1. And we need to transform our interval at this point. So if it was minus pi to x to pi, let's double it up first and then subtract. So minus pi minus 1.107 is minus 7. You can't see a thing that I'm doing. Minus 7.39. And on the top end, would be 5.176. So that is the range I'm looking for. Now, sine of that thing is 1 over root 5. So we can do inverse sine. I mean, should I be showing you this? Probably. But, okay, so the first value I get, first of all, sine is positive. So 2x minus 1.107. My calculator value is 0.4636. I expect x to have 2 solutions in 2 pi. So I expect 2x to have 4 solutions. So I want to find 4 of them. So we've got that as our first value. We will also have from the cast diagram, it's positive. So we want the S region, which is going to be pi minus this guy. Now, pi minus this guy is equal to 2.678-ish. That is still in range. Am I going to get... Oh, if I add 2 pi to that, it's going to go out of range. So in both of these, I need to subtract 2 pi as well. So that guy minus 2 pi, I will also get minus 3.605 on this one. 0.4636 minus 2 pi, I'll get minus 5.820 on that one. And we have to solve all of those for x. So 2x would be equal to that thingy plus 1.107. I would get minus 4.713-ish. This guy, minus 3.605 plus 1.107. I get minus 2.498. This guy, 0.4636 plus 1.107 is 1.5706. 2.678 plus 1.107 is 3.785. And then we divide them all by 2. This just doesn't feel like how they wanted you to do it. And I'll do them all to 3 sig figs now. So minus 2.498 divided by 2, minus 1.25, 1.5706 divided by 2, 0.79, 3.785 divided by 2, 1.89. Okay. Those are what I think my x values are. Luckily, trig is very easily checked by plugging answers back in. Now, here on 18, final question, I believe. Yes. Let me zoom out so I can see what's up. Calculate the sample mean. So the sample mean is 31164.7 all over 120. Which is 259.7. Three significant figures would be 260. Now, that was a good example of the exam technique. The second you think you're done with the question, reread it to make sure you've actually got over the line. Find the number of days on which between... So find this number of days. Well, the frequency density is 6.2, and you multiply that by 5. And so that's 31 days. 18C, give 2 reasons why a normal distribution may be an appropriate model. So the data are roughly symmetric about the mean. Which is one important requirement. The other important requirement is that daily water consumption is continuous data, which you have to be for normal. So daily water consumption is continuous. Okay, 18D. Riley uses the sample mean and the sample variance, both to 3 sig figs, as parameters of a normal distribution. Use the model to calculate the probability. Well, they don't give us, that feels like way too much for 2 marks, because well, let's work out the sample variance. So that would be 8101050.91 all over 120 minus 31164.7 all over 120 squared. Wait, I remember getting into trouble with this before. Do you guys use a different formula? Do you guys use a different formula? I now need to make sure I have your specific mark scheme, your specific data sheet. Nope, that's a physics data sheet. From the booklet. Which form of the book? This looks like the Edexcel one. No, this is the OCR one. Let me make sure you guys have so let me find it. There it is. I think you guys might be different. You're using n-1. Sample variant. Well, that's sample variance. Well, this is a sample. Okay, so let's do this. Okay. We need to change this up. I've used the wrong thing for what you use. So you have, let me copy down the things, right? Sigma x is 31164.7. X squared is 8101050.91 and equals 120. Let's do this. So here, the standard deviation is 1 over 119 into sigma x squared, which is 8101050.91 minus 31164.7 squared all over 120. This thing is, so 1 over 119 times 8101050.91 minus 31164 Look how careful I am not to mistype anything. I am checking every single button press, and I get 62.156. In other words, the standard deviation is the root of that, which is 7.88. So that's D. Now, this is what I mean. There's not a lot of room, and we needed that in order to do the normal distribution. Unless I was just supposed to plug this into a table. I don't know. But the point is now I can begin to use the normal distribution and say that X is distributed normally with the mean that I calculated as being 260 and the variance of 62.156. And now we need to work out the probability. I'm looking forward to the mark scheme on this to see if I've missed something drastic here. Calculate the probability that on a randomly chosen day, the household uses less than 2.5. Oh, I'm an idiot. No, use the model. Because I could do it from here. It would have been very easy, but that's using the histogram, not the model. So use the model to calculate the probability of using less than 250. So the probability in this case that X is less than 255, any distributions I vowed to you that I would show. So let's exit out of here. So this is normal less than. That's interesting. I should have noted that earlier. So 0.1364 it should have been. Where was this question? Hold on a minute. That was finding the critical region of a hypothesis test. When did I do that? Where did I find a critical region for a hypothesis test? I have genuinely no idea, which is super, super unhelpful. There it was. It was 13C. Let me just check that. The critical region was, it was in fact, I tell a lie, 0.136. You see that it truncated it, but it did not round it. So I needed to press the exit button to just check that. See, sneaky, sneaky, sneaky. Those should have been 164s. Noted. All right, so now, where am I actually trying to use this thing? So I'm on question 18. I'm into here. I've already done my stuff to work out the parameters to put in. Less than 255, I believe. Hold on. Yeah. Okay. 255 is my X. My sigma is, I'm going to call that 7.88. My mu is, I'm going to call that 260. And I get 0.263. Okay. I still think there was an easier way to do that for 2 marks. I just don't know what it is. Calculate the probability that the household uses less than that on at least 5 days. So that's the probability. So now we're going to say, why is the number of days using less than 255? We'll distribute that binomially. We're going to do it 28 times and use that 0.263 in the binomial. Probability that y at least 5 days is bigger than or equal to 5. I think this calculator, the CG50, will allow me to do that directly rather than do the 1 minus version. So I'm going to exit, go back to binomial. So this tail I want bigger than or equal to 5. Num trial 28. Now remember, if you were not using this calculator, your calculator might only have the binomial CD, which would require you to say that's 1 minus the probability that y is less than or equal to 4. So just be careful with that. Now, num trial 28p is 0.263. Let's execute that. I get 0.895. And finally, the company which supplies water makes charges relating to water consumption. Adapt the model for daily water consumption to model the daily charges. Oh no. As approach normal to model the daily water consumption. So X was distributed normally with 260 and a variation of 60, well, 7.8. Oh God. So now, well, now this is just coding, right? So let's say that the charges. So the charge is 0.18 times X, the amount consumed, plus 7.8. So therefore, we know that the mean C is 0.18 times 260 plus 7.8. So so this is coding, in other words. And you get 54.6 pence is your mean. And we know that the standard deviation of C is equal to 0.18 times the standard deviation of X. The 7.8 will not affect how far on average things are from the mean. So it's 0.18 times the standard deviation of X, which I found to be 7.88. And I find that that is 1.42. So in other words, this tells us that the cost will be distributed normally with a mean of 54.6 and 1.42 squared. Okay. First thing you should do is check to make sure you've answered every part of every question. I have not yet been that silly on one of these where they actually lay out the individual parts. Although I suppose you can check as you slowly wind your way back that every single little bit has an answer in it. I do agree that is the case. Now I'm going to go through checking technique. I may not check every part of every question, but I will show you what I think the more interesting things are. So for instance, here, let me just plug some things back in. So here, let me go back to menu. Let's actually go back and can you imagine actually calculating something? Outrageous. So, whoop, no, why? Clear, stop, no, desist. So here, let's just do A over 1 minus R, which is minus 1/3 is go 27 over 4. I'm happy. If I'm really pressed, I'll just actually write out the first few terms and show myself that I'm getting close to the value that I expect, which is 6.75. SD, so we are getting close to 6.75, and I feel good about that. Okay. So here, equation of a circle is this thing. Honestly, best thing to do here is to work backwards, maybe. Rather than, I was tempted to plug something in on both sides, but I don't think that's going to be as good. No, screw it. I am going to do that. Because we know, it should be fairly easy to work out a point on this curve. Because we know that it is centered on 6 minus 4, and the radius is 7. Then I know over here, it should go through -1, -4. And if I go up here, it should go through 6, 3. I'm going to use that because they're both positive. But you can very easily work out points that are on both curves. And it should be fairly straightforward to show that that point lies on... Oh, stop it. Stop it. Should be fairly easy to show that that point lies on both curves, right? So if I plug in 6 into there, you would get 6. No, come on. Press. Come on. No, stop it. Stop it, please. 6 minus 6 squared. And 3 plus 4 squared. Let's confirm that is 49. Yep. And let's plug it into here and confirm I get 0. 6 squared minus 12 times 6 plus 3 squared plus 8 times 3 plus 3 is a clean 0. So yes, that point lies on both of them. The radius is 7. The coordinates of the center are 6 minus 4. I feel good. This one, we're just going to plug it back in and check we get the right thing. So 64 over 49 to the power of minus 3 over 2 is that good. Here, determine the value of p. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. P is 0.1. I can even check this. So 1, 2, 3, 4, 5, 6, 7 lots of 0.1 plus a final lot of 0.3 does give me the one that I want as the sum. Find the probability that a score of at least 4 when rolled once, so that is 0.7, it just is. Determine the probability of an 8 occurring twice. This is just rerunning, to be honest. I'm not going to do that. I did it before. Here, determine the exact length of AB. I like what I did here. It's flip the sign on that to get AO, add the OB on. So it is 2 minus 2, which is 2 root 2. I'm happy. Determine the Cartesian of this form. I would be happy doing the same thing that I did before, actually. So because we know this is a circle with radius, with center of minus 3, 1, and a radius of 2, I know it's going to go through this point here of minus 1, 1. I can confirm that that lies on this by plugging it in. So minus 1 plus 3 squared and 1 minus 1 squared does equal 4. And what I can do is to solve for theta and just check that it works for the parameter. So when 2 cos theta minus 3 equals minus 1, it means that 2 cos theta is equal to 2, which means that cos theta is equal to 1, which means theta is equal to 0, which is super, super handy. In fact, that's what I could have done from the start. I could have plugged in theta equals 0, x would have been minus 1, y would have been equal to 1. That does lie on the line. In fact, I can keep going around that. So when cos is equal to pi over 2, for instance, that would be 0, so you would get minus 3, 3. And minus 3, 3 is that point up here. So this just does work. This works. Determine the value of k. Well, all I'm going to do here is plug the value of k back in and confirm I get this as my coefficient of x. Now, can I remember how to do n choose r on this bad boy? I don't think I do. It's so easy on the other one. I really hate the fangled calculator. Is it got a probability or something? Can't remember. Let me quickly Google this. How to do NCR. NCR on a CG50. Press the something button. Then press something. Okay, this is not helpful. La 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 la. I don't have to watch a YouTube video. I may have to. Okay. Turn off the speaker though, so that it doesn't show the sound. That'll disturb. So it looks like we go to option. Is it stat? No. Option prob. There we go. NCR. So that is 12, choose 8. So 12 choose 8 times 2 to the 8 times, I got k as being 5 to the 4, and that gives me good. Okay. Right, so then going into B is the thing about stats is it's not very checkable. So this, you can't really check that. This, you can check that by saying the 110 that you get minus the 18 all over the 120 is, well, let me just do times 100. Oh, come on, I have to click back in. I just don't like it. Yes, so it's good. So that is above the 75. I don't like it. I'm not going to check my explainers. I'm going to check the math. So 2009, let me just plug that in. Stop it, stop it. So it is 1115 times 2009 minus 2212950 is a value. I don't have any knowledge of the pre-release material. Now, I know on the Casio, the ClassWiz, at least the old one, there's a very simple integral button. I don't know how to do it on the CG50. I'm going to have to get real good at using the CG50. So I'm kind of, you're watching me learn on the spot now how to do integral on CG50. So it looks like that's not the CG50. Please hold while I learn to click the button. From the menu button, go to equation. Oh God, no, why? No, stop it. And go to solver. Press option, then F2, then integral. God, you have to just learn how to do these, don't you? The old one had a button. 4x cos 2x, which I will put in brackets, and that is between 0 and, so it's important that you know how to make best use of your calculator, because you can plug these things in and know for certain whether you've got them right. Okay, so it doesn't give it exact, but this thing, oh. No, that doesn't. Wait, what? Why are we solving for x? No, I don't want to solve for x. Why is it saying x equals? Hmm. So navigate to the end after an input. Okay, so I don't think I know how to use this super well. Like, it's so frustrating because the old class it was so simple. But that's not what I meant. Apologies. I'm gonna have to learn how to do that. Why is this so complicated? Navigate to the end after dx and input equals. Wait, so do we want... Am I gonna get there quickly, guys? Probably not. No, we want an equals a. How do we get equals, though? How do we input an equals? Ah, hold on a minute. So that... Hold on a minute. So going into here, they seem to suggest... Now, I'm determined now. This thing equals a equals 0. No, it doesn't, though. All right, I'm gonna have to learn how to do this. But in theory, it can be done. In theory, it can be done. I wish I had the old emulator. If you have the... All right, apologies. But if you can learn how to do that, that's how to do it. So if I do that on my old calculator, so for instance, I can get there exactly. I can get the integral, it's 4x cos 2x between 0 and... See, this is what they put all these updates out and they give you a fancy pants thing and it's not actually any good. So my thing gets me a very quick 0.5707963. And I can confirm that pi over 2 minus 1 is equal to the same thing. So I know that's correct. I just need to do a bit more work on my CG50 to get good at sort of inputting that. But that is how you would do it, like if you can, rather than rerun it where you might have made the same mistake again. So 11a. So if this is true, it is directly proportional. When that is to... Yeah, this works by plugging it back in. So is this true? When x equals 4, that becomes 8. Y does equal 10. And then you do get the same dy dx. So I like that. Question 12, one to many, blah, 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 blah. Not much to check there. Apart from maybe... Well, no, just g of h is actually quite simple. I'm not going to check that. That's good. So this one, 13, again, not much to check, more of redoing, to be fair. So I think I'm okay here. How should that be cleaned? Yep, give 2 reasons, very, very wordy. Not much to do apart from just redo it. But I like that my values, I did get 3 things from that. This looks a bit more checky. So let's confirm when y equals 1, x equals 2. That is correct. When I plug that in, 12. Yep, yep, yep. It looks good. And I can confirm that the point 2, 1 lies on that line, and it does. So I'm satisfied with what I'm seeing. I like what I did with the two-way table. Okay, 17, let's have some fun plugging that back in. All trig, super easy to verify. So here, let me go back. Hold on, let me go back to that, back, forever back. Menu, run matrix. So minus 2.63. Let's plug that in to this. So what I'm going to do, let me zoom in just so you can see a bit better. I'm going to plug all of my answers back in to something that should get me a clean 0. So 2 sine. Now on here, the answer is there, which I should put into a bracket probably just to avoid any issues. Plus 1 over cos answer. Do not like the CG50. Minus 4 cos answer should get me something close to 0. I think that's good enough with rounding error. And I wonder actually if this is where CG50 can help. If I can just, no, not that. So minus 1.25 minus 1.25 minus 1.25. Again, close to 0. I'm going to plug in 0.79. Nope, lies. You see, that at least that shows that it is capable of going off if I don't do it correctly. So it should be 0.79 everywhere. Yeah. And just to be safe, I'm going to do the 1.89. $1.89. No, why? 1.89. Yeah. Okay, so those look good. And then we get into 18, where again, I'm super interested to see how that was supposed to be done. But I am otherwise fairly satisfied with what I did, and I really just want to get into the checking now. So mark scheme time. All right, let's get to the start of the mark scheme. And let's see, well, let's see in particular how good my wording was, or rather how bad my wording was. So here, 27 over 4, good. Is it really plus minus? Is it really plus minus? Hold on a minute. Oh, what? What? What did it ask for a circle? What are you talking about? Oh, it just wants the radius. So the radius is 7. Okay, there we go. The center is 6 minus 4. Great. Okay, cool. Yeah, you get that. P is 0.1. Good. Did I really need to? Ugh. Boo. 0.7. C 0.0018. Perfect. 2 root 2. Yep. X plus 3, y minus 1 is 4. Yep. K is 5. Not a random, since each possible sample. Okay, they did want that. So it's not the individual. Simple random means each possible sample has an equal probability of being selected. You can see I was umming and ahhing about that, but yeah, they seem to want that definition, which is good. I accidentally gave the definition for just being random, not simple random. Oops. But this is bigger, so that's good. Since different samples give different results, not all samples would necessarily support the owner's claim. I hate that. Well, that's kind of what I said. Random variation in samples mean that some might not support it, but like terrible, terrible, bad. Do not like. Samples, since not all taxpayers included, only some of the data is used. Cool. I got that. Interpolation. This is between that. Straight line appears justified, which is my second point. Cool. I completely guessed D. I'm not gonna lie. So what was D? 9D. Use your knowledge of the pre-release material to explain whether the model would give a reasonable estimate. What was I supposed to know? Not reasonable, since medium income varies considerably across different regions. Wait. But this was... Oh, I didn't read the question. God damn it. This was for Camden, and we needed to do it for Croydon. Okay, my bad. Okay, so you can't take Camden and say it's going to do Croydon. They vary across regions quite significantly. That was me not reading the question. Sorry about that. 10. Yeah, you get your pi over 2 minus 1. 3 over 2 root x. X is, 3 over 2 plus 2. It's a... Yeah, it's neither of those. It's a one-to-many, which means it's not. Surely you include the variant. Allow because it's one-to-many mapping. Yeah. So this is, x squared plus 2, x squared minus 1. I'm really curious about this. Yes, okay, the modulus of x is bigger than 1. But I'm surprised it was a state that, given how much work you kind of had to do to get there. So here is the population mean mass. Allow weight. So they're not saying mean mass, they're saying population mean mass, I suppose, as opposed to sample mean mass. God damn it, I hate stats for how annoyingly pernickety it is with the wording. I don't know where they got a 0.199 from. The question very, very clearly said, oh no. Wait, why are they using S instead of sigma? Oh, because it's sample? Oh, God. So your syllabus seems to really get into the difference between sigma and little s in a way that the edXL really doesn't. So that's something I didn't know coming into this, and apologies for that. But yeah, so drawing your attention to that, that's a really annoying part of the syllabus. Critical region 0.163, and yep, got that at least. This is outside the critical region. Reject H naught. Sufficient evidence to conclude that the mean mass is less than 0.14. Okay. Discard City of London. Yeah. It does not look linear, which is the second point that I said. PMCC not close to 1. Good. 18861. Yep. And then, yeah, I got those right, and I circled the right 3. Correct here that it would be outliers give a false impression of linearity. Scatter will look more like a circle. I kind of said grouped together. Yeah. So this gets me nice. I like that. Now I'm on to 16, 2.688, 0.07. 0.12. These are not the same, so not independent. Good. Divide through by cause. You see, I knew. God damn it. I knew that wasn't how I was supposed to do it. It just felt wrong. I got the right answers, though. That... Yeah. 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 So I did get them, but that's not how... Okay, I just knew that something was off. So what should have been done here? Let me go down to the extra space to show you. So what should have been done here, if I redo the question the way it was intended, what I should have spotted, so sec tan are related. So I should have spotted that if I divide through by cos, I get 2 tan x plus sec squared x is equal to 4. And sec squared, well, I can actually never remember. So sine squared plus cos squared equals 1. Divide through by cos squared, we get tan squared plus 1 equals sec squared. So this is 2 tan x plus tan squared x plus 1 equals 4. So in other words, tan squared x plus 2 tan x minus 3 equals 0, which means that tan x plus 3 tan x minus 1 is equal to 0. So tan x is equal to minus 3, or tan x is equal to 1, which means x is equal to pi over 4 minus 3 pi over 4 from this one. And then you can do inverse tan of 3 on this one to get the other two values we got earlier. I just didn't spot that. But you can see, okay, you can tell when you're not on the ideal solution path. You can just tell. But if you have mathematical skill to use, which is going to get you the correct answer, use it. So I still would have got the marks. Now, actually, let me check on that. Let me confirm that that would have been... I mean, I'm sure it would have been. Yeah, multiply through by cos to get that. But even here, what would they have wanted? Because even here, I didn't do what they wanted using this path. What did they want from this point? They did say that. They did say that, so I got there. Okay, so I used this. So I did use that. Okay, cool. But what did they do? They said... How did they do that? How did they relate sine 2x to cos squared 2x? I have no idea. Use the double angle formula. So they... No idea how they got there. Interesting. How did they get there? I'm now... How does that follow? I have no idea. Oh, right. Square both sides. Oh, that's what they did. Oops. Read on, Patrick. So square both sides, convert that into cos squared, move it across, done. Squaring both sides so that you... Okay, so if you've got a sine on one side and a cos on the other side, they suggest squaring both sides so that sine squared plus cos squared equals 1, or that we can convert the sine squared into a cos squared to get it all in one function. So that makes sense. So there were two times where I didn't use the intended solution path, but I knew I had a skill, I used a skill, and it worked. That was insane. So in other words, what they're saying from here, if I had sine 2x, yes, sine 2x plus 1, where was it? I'll show you where we got to. So here, they got to sine 2x plus 1 equals 2, because I'm not just doing this for your benefit, by the way. I want to practice this skill. I want to lock the skill in. So they square this side, and you get sine squared 2x plus 2 sine 2x. No, because what you have to do, you don't want to have that. So what you've got to do is to instead call that, so sine 2x equals 2 cos 2x plus 1. Then we can square both sides. 4 cos squared 2x plus 4 cos 2x plus 1. And then we can say that's 1 minus cos squared 2x. And then we can say 0 equals, the 1s will cancel on both sides, so it's 5 cos squared 2x. I've never used this technique before, but the point is you can take a cos 2x out and be left with a 5 cos 2x plus 4, which either means that cos 2x is equal to 0, which you can solve for, or cos 2x is minus 4/5, which you can solve for. Wild. I genuinely, I have never seen such an interesting trig question, and it looks so simple. I'm going to hold on to that one. Not going to forget that one in a hurry. So then getting on to 18. So 260, 31, symmetrical, continuous, good. 62.2, good. 7 point, they're saying 7.98. Oh, or that. So, okay. Yeah, cool. So I got that. And then the probability is 0.263. Yeah, good. Here, a probability in this range, which I did get. And then here, and good. Okay. I feel okay about that. So in conclusion, apart from that trig being some of the most outrageous trig I've ever seen, the main thing for me was, again, the wording on the exact definition of a simple random sample. And these are all the little things you're going to want to do when you get into the stats, by the way. If you have that coming up this week for the MEI paper 2, if you've got that coming up, I know OCR A as well. No, that's your paper 3 has your stats on it. I know the EdXL next week is going to have your stats on it. But when you get round to your stats, make sure you know your large data set or given material. I didn't quite read the question right when it came to the Camden versus the Croydon. But again, those wordy definition things, that's where the little marks get lost on the edges, as you can see in the stats. So all my calculations were correct. I think what I also need to do, given that I've run out of my emulator on the FX991EX, I need to either get the emulator for the 991CW and have that in parallel use that. I also need to work on my CG50 skills. That's a me problem, but it's also a you problem, just making sure you know what exactly your calculator can do to help you. Not everyone knows that you can use, for instance, your calculator to convert from hours to hours and minutes, or using it to find exact differentiation or integration in a way that you can check your work and know you're right? So making sure you're really, really honed in on your calculator skills, all the useful ones. And I should probably spend some time this summer getting good at it and put out a general, here's all the things your calculator can do stream. But as you guys know, I hate buttons and I don't like pressing them. But right, so that's been about a couple hours. That's how that paper goes. Hopefully you gained something from that. If you've got your sort of paper 2 coming up this week, good luck. And I will see you guys. Yeah, I'm going to put out a final Math 3 sort of a comprehension paper next week. I don't think I'm going to do a debrief. I could do a debrief on the paper too, I suppose. When could that be? I couldn't do it on the Friday, unfortunately. I could maybe do it on the Friday after FM1, maybe. If I do that earlier, if I could do it maybe a 4 to 5. That might make more sense while it's fresh. So I'll pop that in. So we can talk about the math paper 2. We could also talk about the further mechanics if you guys want. And then it's just the final week. You guys have got like 9 days to freedom. Make the most of it. You're so close. Keep working hard. Make it through the finish line. I will see you guys on the other side. All right. Take care. Bye-bye.